3,000 meters below the surface of the Pacific Ocean, there is a whale skeleton lying in the dark. It has been there for years. The flesh is gone. The blubber is gone. Everything that could be eaten by something with teeth was eaten a long time ago. But the bones are not bare. They are covered in something that looks like a garden. Thousands of red feathers, standing upright, swaying in the current. Soft, bright, almost beautiful. From a distance, it looks like a meadow of flowers growing on a corpse. They are not flowers.
They are animals, and they are eating the skeleton.
Now here is the part that stopped scientists cold when they first pulled one of these creatures out of the water and cut it open. It has no mouth, no stomach, no gut, no opening of any kind. There is no way for food to enter this animal. And yet the bones are disappearing. February 2002, Monterey Canyon, off the coast of California. A research team was running a remotely operated submarine, a robot on a cable with lights and cameras, crawling. They were not looking for a new animal. They were mapping the canyon. Then the lights caught something on the bottom. A shape too big and too regular to be rock. It was a gray whale, or what was left of one. A skeleton, roughly 10 meters long, resting on the mud at a... And it was red. The camera moved closer. The red was moving. It was thousands of small, feathery plumes, all growing directly out of the bone, waving together in the slow, deep current. The team collected samples and brought them to the surface. Back in the lab, they started the dissection. And nothing made sense. There was no mouth. They looked again. Still no mouth. No jaw. No teeth. No stomach, no intestine, no anus. The entire digestive system that every animal of this kind is supposed to have simply was not there. What they had instead was a root system. The part they had seen on camera, the red plume, was only the top of the animal. The rest was buried inside the bone. Let's look at what this thing actually is. A female is small, depending on the species, somewhere between 1 and 7 centimeters long, smaller than your finger.
At the top, there is a crown of feathery red plumes. Those are gills.
The red is blood, the same iron-based pigment that makes your blood red, doing the same job, pulling oxygen out of the water. Below the plumes is a soft trunk, wrapped in a clear tube of mucus that the animal secretes around itself. If you touch one, it feels like slime. One species found in Sweden was nicknamed the bone-eating snotflower. And that is not a scientific insult. It is just accurate. Below the trunk, the animal changes completely. The bottom half is a green, branching mass that grows down into the bone. It has no fixed shape. It follows the internal structure of the skeleton, filling the spaces, wrapping around the dense parts, pushing deeper. These are the roots. This is the part that does everything. To understand how an animal with no mouth eats a skeleton, you have to stop thinking about whalebone as bone. A whalebone is not dry and hollow like a bone on a dinner plate. In a large whale, a huge fraction of the skeleton, in some bones more than half the total weight, is fat and protein, oil, locked inside a hard mineral cage. That skeleton is one of the richest packages of food anywhere on the deep seafloor. The problem is getting inside it. Osedax solves this with chemistry. The skin of the roots is packed with molecular pumps that push acid outward, directly onto the bone.
The worm has taken that machinery and pointed it at a skeleton.
The acid dissolves the mineral. The cage opens. The fat and the collagen inside are released. But the worm still cannot digest them because it has nothing to digest with. So it does not. Inside those roots, in specialized tissue, the worm carries billions of bacteria. It is not infected by them. It farms them. The bacteria break the whale fat and the collagen down into simple molecules, and the worm absorbs them straight through its tissue. The animal you are looking at is a delivery system. It anchors, it dissolves, it feeds its bacteria, and it takes its cut. And it works fast. Sink a fresh bone in the deep sea, and within months you can see the holes. Give a colony enough time, and a skeleton that could have lasted for centuries is reduced to fragments. When the first specimens were studied, researchers noticed something odd.
Every single adult worm they examined was female.
Hundreds of them, thousands of them, all female. There were no males anywhere on the skeleton. The males were found later, and they were not on the bone at all. They were inside the females. A male Osedax never grows up. It settles, and then it stops.
It stays microscopic, so small you need a microscope to confirm it is an animal.
And it lives inside the mucus tube of a female, sometimes with dozens of other males. In some tubes, researchers have counted more than 100.
They never develop roots. They never develop plumes. They never eat anything at all. Each male still carries the yolk sac it was born with, the same droplet of food it had as a larva, and that is the only meal it will ever have. It burns through that reserve, and it dies. Its entire existence is to produce sperm, and to be in the right place. That is the full life cycle. The females take the skeleton apart. The males live in their mucus, starving, in the dark, by the 100. To understand why this animal exists, you have to understand what happens when a whale dies.
A large whale is 50 tons or more.
When it dies and sinks, it hits a seafloor that is essentially a desert, cold, black, and almost empty of food.
Because almost nothing grows down there. Most of the deep ocean survives on scraps drifting down from the sunlit water above, and there are very few scraps.
Then 50 tons of meat lands on it. Scientists call this a whale fall, and it happens in stages. First come the scavengers, sleeper sharks, hagfish, crabs, and swarms of small crustaceans that strip the soft tissue. That phase can take months to a couple of years. Then come the opportunists, worms and snails that move into the enriched sediment around the carcass,
feeding on what the scavengers left behind.
Bacteria break down the fats and release sulfide, and around that sulfide, an entire community grows decis, mussels, clams, tube worms, The same kinds of creatures that live at hydrothermal vents.
Mussels, clams, tube worms, the same kinds of creatures that live at hydrothermal vents.
A single whale skeleton can support that community for decades. In some estimates, most of a century.
One dead whale becomes an island of life in a desert. And Osedax is what dismantles the island.
Which raises an obvious question. If your only possible food is a whale skeleton, how do you ever find one? You do not find one. You release millions of larvae into the open ocean and let the current decide. An Osedax larva can swim, barely. It cannot feed. It drifts, carrying a tiny reserve of yolk, and it has one instruction: find bone. Not mud, not wood, not a dead fish, bone. If it lands on anything else, it dies. When researchers began deliberately sinking bones on the seafloor to test this, including ordinary cow bones from a butcher, the larvae found them. Not after years, within weeks and months. And once people knew what to look for, Osedax turned up everywhere. Off California, in the deep basins of Japan, off Brazil, in Antarctic waters, and in a Swedish fjord at a depth of about 30 meters, shallow enough that a diver could reach it. Roughly 30 species are now known.
They are not a rare curiosity from one canyon. They are a standing feature of the world ocean. Every bone that falls is already being watched.
And now the last piece, which is the strangest one. Whales, in their modern form, have existed for a few tens of millions of years. Osedax eats whalebone. Then researchers started examining much older fossil bones with the specific question, are these holes?
They found borings that match Osedax root cavities in the bones of marine reptiles to 4.
Animals from the age of the dinosaurs, roughly 100 million years old. Plesiosaurs, sea turtles. Long before the first whale existed, something was already sinking to the bottom of the ocean and being taken apart from the inside.
Which leads to an uncomfortable idea that paleontologists now take seriously.
There is a long-standing gap in the fossil record of ancient whales and marine reptiles, bones that should exist and do not. It is possible they were eaten. We tend to imagine the deep sea as a place where things settle and stay. Cold, still, preserved. A place where a skeleton lies undisturbed for 1,000 years. That is not what the deep sea is. Everything that falls is claimed. The flesh goes first, in weeks. The oil goes next, over decades, into bacteria and mussels and clams. And then the bone itself, the last thing, the hardest thing, the part built specifically to outlast the animal, is dissolved by something with no mouth, no stomach, and no interest in anything else. Right now, somewhere below you, there are red plumes swaying over a skeleton in total darkness. There always are. Nothing waits down there, not even the bones.